Today in repair, 4-channel power amplifier ACV model LX14100 is 4 channels of 100 watts each. Maximum power is 1500 watts under some conditions I don't understand. The case is quite large but very light. Here we have the power connectors, 2 30 amp fuses, and the speaker output with a picture of the wiring diagram by channel and bridge. On the opposite side are symmetrical filters for channels 1, 2 and channels 3, 4, RCA inputs, and a connector for connecting a remote regulator. This amplifier was purchased knowingly. In a faulty condition, the seller said that the output transistors burned out. Before that, it was already in repair, and there is a suspicion that was soldered Chinese fake, which worked for 2 weeks. A friend of mine bought it and brought it back to me to revive it again. When power is applied, nothing happens. Neither red nor green LED is lit. But the power supply goes into current limitation, which indicates a short circuit. Removing the bottom cover, we get access to the contents of the amplifier. We see the board covered with a beautiful black solder mask. The amplifier blocks are clearly separated. Filter block, power amplifier block, and boost converter block. By the number of chips in the filter block, we can assume that the filter board here is quite advanced, and we can hope for good sound quality. There is 1 pair of transistors per channel in the terminal amplifier, so you can't count on very high power. Well, the converter is apparently separate for front and rear. They look exactly the same, 2 electrolytic capacitors each. The input capacitance is 2200 microfarads, 35 volts. The output is also 2200 microfarads, 35 volts. Let's try to check this transistor with an arrow tester. We see that the resistance of one of the transistors is 0, and the same with its neighbor, which means we're gonna have to replace this pair. On the other side of the moon, everything is fine. Now we unsolder this channel and check the transistors. Removed the board from the case and can see that 1 pair of transistors has already been changed. The names of the transistors are the same, but their housings look completely different. But by the way, the suspicions of its last owner were not justified and burned out a pair of, not that was changed, and native. Control check. Yes, the transistors are 100% replaceable. Let's try to turn on the amplifier without this pair of transistors. The green indicator lights up, everything is fine. The transistors are resoldered. I changed 2 pairs at once. I didn't have 1047 and 817, so for symmetry I soldered 718, 688. The transistors are tested. I didn't buy them in China, so they should hold the required power. Let's check. The green indicator is on. Consumption is 600 milliamperes. All good. Check if there is sound at the output. All good. We can bite off the transistor leads and assemble. Everything is done, but I had to refine it a little bit more. As it turned out, the bridge connection in it is not like this, but like this. And so I swapped 2 pairs of transistors so that we have the same transistors in the bridge. And let's plug it in now and measure the power. First in the channel, then in the bridge. Since we have a 12 volt 50 ampere power supply, the measurements will be more qualitative. So to say double pulling on the plus and the minus. And also a very powerful load resistor, resistance of 4 ohms. The manufacturer promises 100 watts per channel at 4 ohms, or 300 watts in a bridge connection. Let's get started. Let's check the resistance of the resistor, approximately 3.6 ohms. Let's check it with a digital multimeter, 3.7 ohms. So that's what's going to go into our calculations. Frequency is 1 kHz. Let's raise the power to a clip. 17.2 volts. 80 watts exactly. Now let's switch to the bridge. 10 volts per division is not enough. Make it 20. Let's say 29.6 volts. That gives us 237 watts at 4 ohms. And if you crank it up to full, 350 max. That's not bad. This is more of a review than a repair. The repair is simple, just replace the transistors. But I made a review, I hope it was interesting. Thank you for watching this video. Good luck to everyone.